Let's see how to find out the displacement and distance traveled when velocity function is given. So we know that displacement is the change of position of a particle, whereas distance traveled is the length covered. So here we have a question which asks us to find out the displacement and distance traveled and when the velocity of a velocity function is given. So let us see how to find out the displacement and distance traveled when the velocity function is given. So we know that velocity v of t is nothing but the rate of change of distance, that is ds by dt. So if you want to find out the velocity when if you want to find out the displacement when velocity is given, we need to integrate. So if I integrate the velocity function with respect to t, then it is integration of ds by dt with respect to t. So integration and derivative will get cancelled. So therefore, if you want to find out the distance, that is s is equal to integral of v of t dt. So now we know that how to find out the value of s when the velocity function is given. So let's use it in our given problem. So the problem says that a particle is moving along a line so that its velocity at time t is v of t, that is equal to t square minus t minus of 6 meters per second. So we need to find out the displacement at this given interval of time and also the distance traveled during this time period. We'll start with finding of displacement. So we know that s is equal to integral v of t dt, and since you know that the time interval is from 1 to 4, we are going to find the integral from 1 to 4. Now integrate 1 to 4, we know the value of v of t, that is they have given that v of t is equal to t square minus t minus of 6. So substitute the value of v of t, that is t square minus t minus of 6 dt. Integrating this function, t square becomes t cube by 3 minus t square by 2 minus 6 will be 60. After you integrate, you are going to apply the limits. Now applying the upper limit minus of lower limit. First we apply value as 4 wherever you have t. So replacing t by 4. So we get 4 cube by 3 minus 4 square by 2 minus of 6 times 4 upper limit minus the lower limit, that is 1. T will be replaced by 1. 1 cube by 3 minus 1 square by 2 minus 6 times 1. Now simplify this. Simplifying the first bracket, we get minus of 10.667 minus of, simplifying this, we get minus of 6.167. So that's minus of 10, minus of minus will be plus, and when you simplify this, we get the value as minus of 4.5 meters. And this is the value of the displacement of the particle. Displacement. So we have here negative, and displacement can be negative as displacement is change in position. So change of position might be backwards, which may give you the value as minus. Next, looking into the distance traveled during this period, that is from 1 to 4. Solving for B. Again noting down the velocity factor given, that is v of t is equal to t square minus t minus of 6. So if you want to find out the distance traveled, distance traveled, we need to integrate the velocity from 1 to 4. But since distance traveled is always positive, we need to find the modulus function of v of t, that is the absolute value of v of t. So there's a slight difference in finding out displacement and distance travel. So when you're calculating distance traveled, since distance traveled should be always positive, we need to look at the points where it can be negative as well. So for that, what we do is we need to factorize this function. So we'll be factorizing t square, that is the velocity function. Always to find out the distance traveled, we need to factorize the velocity function. So velocity function is t squared minus t minus of 6. So factorizing this, 6 times 1 will be 6. So when we factorize that, we get 2 times 3. Factors of 6 are 3 times 2 or 2 times 3. We write it as 3t plus 2t minus of 6. So now taking terms common, so t is common from here, so we get t minus of 3 plus 2 common from these two terms, so we get t minus of 3 here as well. So now the factors are t equal to 3 from this, and we have t equal to minus of 2. So we can see we have got two values, that is t is equal to minus 3 and t is equal to 3 and t is equal to minus 2. And since we know that our given interval is from 1 to 4, since we are interested in only looking for the distance traveled in this time interval, that is from 1 to 4, and 3 lies in between this time interval where minus 2 is out of this, so we are not interested in finding out the value at t is equal to minus 2. So now after we get the points lying in between these two given points, we are going to check in this the velocity at both of these intervals. So let us take some point, that is 2, which is lying in between these two values, and again a point say 3.5 that is lying in between this interval. Now what we do is we put the value of 2 in the velocity function, that is we find out v of 2 and also v of 3.5. So just substitute the value of t as 2, that is in this equation we put the value as 2 and we get the answer as a negative value. So you can just substitute that and check. V of t will be giving you a negative value, and if you similarly put 3.5 add or else any point, say 3.1, 3.2, anything in this v of t function, we get the value as positive. Okay, so that means that whenever the graph is looked into this interval, it will be always negative, and when you look into here, it will be always positive. So if you are interested in looking into the graph of this, it's somewhat like this. Yes, this is the y-axis, this is the x-axis. So we get the point say minus 2 here, and a point C3, this we can say it as 4. So since they are saying that from 1 to 3 it is negative, that means that part of the graph is lying below the x-axis. So the graph, if you look into, will be somewhat like this, passing from minus 6 on the y-axis and then here from 3 and moving into the positive axis, positive y-axis. So if you see, this is the negative point which we are not interested since we want only from 1 to 4. So if you check from 1 to 4, what is happening is from 1 to 3 the part of the curve is lying below the x-axis, and from 3 to 4 it is lying above the x-axis. So that means here the distance will be negative and here it will be positive. So wherever you have the distance as negative, the value as negative, there we are going to multiply it by a negative minus sign. So we write this as integral 1 to 3. Since we have here 1 to 3 and 3 to 4, we write it as 1 to 3 modulus v of t dt. plus integral 3 to 4 mod v of t dt. Now, as I told you, this here the value of the function is negative. So we are going to multiply this integral by negative, and since this is positive, this will be kept as it is. So integral 1 to 3 minus of what is the value of v of t? It's given as t square minus t minus of 6 dt plus, and here since it is positive, we write the equation as it is, that is t square minus t minus of 6 dt. So now we are going to integrate this with multiplying the minus sign inside. Minus of t square will be t cube by 3. Minus of minus is plus. So it is t changes to t square by 2. And minus of minus will be plus. 6 becomes 60, which is integrated from 1 to 3. Plus, again integration of t square is t cube by 3 minus t square by 2 minus of 6 changes to 6t integrated from 3 to 4. Now applying the lower limit minus the, applying the upper limit minus the lower limit, applying 3 in place of t. So it is minus of 3 cube by 3 plus 3 square by 2 my plus of 6 times 3. Applying upper limit minus of the lower limit, that is 1 minus of 1 cube by 3 plus 1 square by 2 plus 6 times 1 plus the second integral, applying the upper limit, that is 4 cube by 3 minus 4 square by 2 minus 6 times 4 minus the lower limit, that is 3 cubed by 3 minus of 3 squared by 2 minus 6 times 3. Now we simplify this to get the value inside the bracket. So the first value turns to be 13.5 minus of this value turns to be 6.167 plus the third bracket minus of 10.67 minus of the last one will be minus 13.5. Now simplifying this, we get the final answer as 10.163. So this is the value of the distance traveled, and since it's the length, so the unit will be meters. So always the thing to be remembered is when you find out the distance traveled, we need to factorize the velocity function given, and we need to check where the graph is going to be negative, where the function is to be negative, and where the function is positive. Wherever you get a negative value of the function, in that interval we are going to multiply the function by a negative sign. Wherever you get it as positive, we are going to keep the function as it is and then proceed with the integration function.